Hi guys, it's Mrs. Tellas. Happy Wednesday. This is section 8.2, and today we're going to be graphing more parabolas in the form y equals ax squared plus c. Notice that we're leaving that bx out in the middle. So on Monday we did y equals ax squared, and then we're going to add the plus c to it today. And we're also going to be starting to solve for those as well. Okay, so if we write the standard form, we talked about this on Monday, standard form for a quadratic or a parabola is y equals ax squared plus bx plus c. And again, we're going to be writing them without the bx right now. And the quadratic parent function is just y equals x squared. That's what we compare everything to. And then down here, y equals x squared plus 5 is a vertical translation of the parent function. So remember, vertical means up or down based on this number right here. So the parent function, because y equals x squared is the parent function, is going to be moving up 5 because of the positive 5 on the graph. So instead of starting the vertex at 0, 0, the vertex will start at 0, 5 and then mirror the parent function. So what happens to the graph when a is a number other than 1? Well, if it's negative 1/2, first of all, it opens down instead of up like a frowny face. And then since it's a fraction in front of x squared, negative 1/2 makes it wider than the parent function. And wider, another name for that is called a shrink. Okay, so now you click pause and you try these two. Does it open up or down? Is it a shrink or a stretch? Is it wider? Is it narrower? That kind of thing. I want you to be able to tell me that just by looking at the A. Right, so since this is a positive 3 for A, it's going to open up like a smile. Okay, and positive 3 is bigger than 1, so this is more narrow, or it is a stretch. And then negative 5, this negative right here, makes it open down like a frown. And negative 5 is also more narrow, so it is also a stretch of the parent function. So remember that graph if this is confusing you. So between negative 1 and 1, not including those, so we would make those open circles. If I draw that in here, in between here is called a shrink. If the A is in between negative 1 and 1, which means that it is wider than the parent function. And then if we go outside, so including the 1 forever and including the negative 1 in the other direction forever, those are called stretches of the parent function. And those are more narrow than the parent function, both of them. So you know just by looking at that A, first you know if it opens up or down, and then secondly you know if it's more wide, being a shrink, or if it's more narrow, being a stretch of the parent function. All right, so when we find the solutions of the quadratic parent function, we name the x-intercepts. So this is a lot of this chapter, looking at the equations and then finding the x-intercepts. So we're looking for, when we graph it, we're looking for where the parabola crosses the x-axis. Okay, and when we're not graphing it, we're looking to factor. Okay, so using factoring from chapter 7, which is why chapter 7 comes first, we would factor to find those x-intercepts. So you can factor finding x-intercepts. Another way, factor to find solutions, or factor to find roots, or factor to find zeros, or the directions may just say solve. This all means that you're going to factor the quadratic to figure out any of these terms. They mean the same thing, where the parabola or the quadratic crosses the x-axis. All right, so let's start here. Here's my first equation right here, y equals x squared plus 3. So I'm going to go ahead and make my table like normal. Okay, so I've got x and y. I'm going to start with 0. So 0 is in the center because I'm assuming it's the vertex. So if I plug 0 in here, y equals 0 squared plus 3. Well, that's 3. Let's try 1. 1 should be simple. So y equals 1 squared plus 3. That's 4. So if 1 is 4, negative 1 is also 4. Remember, those will be symmetrical. And then let's try 2. 2 and negative 2. So y equals 2 squared plus 3, that's 4. 4 plus 3 is 7. So let's see what that looks like on my graph. So 0, 3 would be up 3. 1, 4 is right 1 up 4, left 1 up 4, and 2, 7. And it makes the same parabola it did before. Now the vertex is no longer 0, 0 every single time like it was on Monday. So the vertex is here in the middle. It is 0, 3. The line of symmetry, remember, it's your fold line that cuts down the center. So in this case, it's the y-axis. So this is y equals 0. The domain is still all real numbers like it was on Monday. Actually, I'm sorry, this is x equals 0, not y equals 0. And the range is the y. So this is y is greater than or equal to everything 3 and above. So greater than or equal to 3. The solutions would be where this parabola crosses the x-axis. And you can see that it does not cross the x-axis. So the solutions here are no solution. Okay, and if we compare this to the parent function, let's draw the parent function here. We have it 0, 0, 1, 1, negative 1, 1, and 2, 4. So the width is the same. The width is the same. You can see that these are 2 little boxes, and then it goes up 3 at a diagonal, and it does that the same. The only difference here is that this plus 3 at the back makes this a vertical translation up 3 or positive 3. So you can see, because there's no a here other than 1, it didn't change the width of it, but it did change where the vertex starts. So I know when I plug 0 in there that I'm going to get 3 just by looking at the equation to begin with. All right, another one together. So if I have y equals x squared minus 4, I would make a table. Vertex is going to go in the middle. So I'm going to put 0 here. So if I peg 0 in here, 0 squared minus 4 is negative 4. And let's try 1 and negative 1. They should have a partner answer on the bottom. So 1 squared minus 4 is negative 3. And let's do 2 and negative 2 since there aren't any fractions. So 2 squared minus 4 is 0. So if we plot all of these over here on this graph, 0, negative 4 would be down 4. 1, negative 3, and negative 1, negative 3. And it looks like it crosses at 2 and negative 2 on my picture. It is exactly like the parent function, except that it dropped down 4. It is exactly like the parent function, except it had a vertical translation of negative 4 or down 4. My line of symmetry is x equals 0 because the fold line still is right in the center. The vertex is 0, negative 4. We put that in the middle of our table. The domain is still all real numbers like it was on Monday. And the range this time, since it's going up, is y is greater than or equal to negative 4. Now on this one I do have solutions because the parabola crosses here at 2 and negative 2. And those are my solutions, or my roots, or my zeros. So my solutions here are 2 and negative 2. And I'm going to put those in a bracket, not an ordered pair, because they are a set, not an ordered pair. All right, let's try another one. Okay, this one is just a little different, not much. It's got an A here, which is either going to make it a shrink or a stretch. You decide, press pause, and you decide if this is going to be a shrink or a stretch just by looking at the equation. And then also decide on the plus 3. Does that make it a vertical translation going up, going down, going sideways? What does that do to the parent function? So we can talk about the translation before we even make the table. So if we make the table and we put 0 in here, y equals 2 times 0 squared plus 3 would be 0, 3. If I put 1 in there, for x, 1 squared is 1, times 2 is 2, plus 3 is 5. And then negative 1 for x would have the exact same answer. And same thing for 2. 2 times 2 squared plus 3, so that would be 4. 4 times 2 is 8. 8 plus 3 is 11. So that would also be 11. Okay, so now we can graph that. And I was predicting that 2 would be a stretch or more narrow. I hope you were too. So 0, 3 would be up 3, a vertical translation. Positive 3 or up 3. 1, 5. Negative 1, 5. And I'm off the graph just a tiny bit, but not too much. But there we go. Oh, I missed that other dot. You know how I do that sometimes. All right, so there's my picture. Here's my picture. You can see that it's higher 3 than the parent function, or a vertical translation of 3. You can see that it's also more narrow than it would be had it been just y equals x squared, because 2, that 2 and the a, makes it a stretch or more narrow. Okay, so that's how I would compare it to the parent function. So my vertex here is 0, 3. My line of symmetry is x equals 0 because it's still that black y-axis. That's the fold line on the parabola. The domain is all real numbers. The range is y is, let's look, greater than or equal to 3. And the solutions, it does not cross the y-axis, so there are no solutions here. All right, let's try the next one. Okay, so before you make a table and graph this, I want you to press pause, and I want you to decide what kind of translation it is based on the C. And then also, is it a shrink or a stretch based on this negative 2? All right, let's make our table. So if we make our table, we'll start with 0. 0 is always the easiest place to start. So y equals negative 2 times 0 squared minus 8. That gives me negative 8. If I put 1 in there, 1 and negative 1 x's are going to match answers. I bet it's negative 7, but let's see. You never know. So y equals negative 2 times 1 squared minus 8. So let's see. 1 squared is 1 times negative 2 is negative 2. Oh, no, it's negative 10. And then I think I'll do 2 and negative 2. It's probably going to be off the graph a little, but that's okay. So negative 2 times 2 squared minus 8. So 2 squared is 4. 4 times negative 2 is negative 8. So that ends up being negative 16 and negative 16. So if we graph this, 0, negative 8 would be down 8. 1, negative 10 is down over 1 and down 10. And then 2, 16, or negative 16 is going to be off the graph a ways. So we'll put it down here. And we'll make our parabola. All right, so let's talk about your prediction before you started. So this 8 right here, this negative 8 meant that it was a vertical translation down 8 or negative 8. And this negative 2 for the A made that a stretch, or made the picture more narrow. So that negative 2 makes that a stretch. So I hope you predicted that. And if you didn't, give that a try again. Make sure you're understanding why it's a shrink or a stretch. Also, if you're struggling with that, you can go to Desmos into the graphing calculator and just type them in so you get a feel for which one's more narrow and which one's wider. It's a good thing to do if you're having trouble. So vertex was 0, negative 8. Line of symmetry is x equals 0 because the y-axis is the fold line. The domain is all real numbers. The range is y is less than or equal to negative 8 because the parabola starts here at the maximum and drops down forever. And then it does not cross the x-axis, so there are no solutions or roots or zeros in this problem. Very good. All right, I want you to press pause, and I want you to try this one by yourself and see if you can come up with that. So give that a try and press pause. So if I make my table, I'm going to put 0 in the center. So if I plug 0 in, 2 times 0 squared minus 8 would be negative 8. So we get the same vertex that we got on the last one. But the other points are going to be different. I can tell by just looking at it because this was a positive 2 rather than a negative 2. So if you look at that last one, the last one had a negative 2 as A, which meant it was going to open downward like a frown. But since this one has a positive 2, this is going to open up like a smile. So I know that these points are going to be different even though the vertex is the same. So 2 times 1 squared minus 8, that's 2 minus 8, which is negative 6. These two always match if you did it correctly. And then 2 negative 2 would be 2 times 2 squared minus 8. That's 4 times 2 is 8 minus 8, which is 0. All right, so negative 2, 0, 2, 0, 0, negative 8 goes down 8, negative 1, 6, and positive 1, 6. So we have a parabola. This one's got solutions. I wonder if you know why this one has solutions. Okay, line of symmetry. There's the fold line right down the middle. That's x equals 0. The vertex here is 0, negative 8. The domain is all real numbers. And the range is y is greater than or equal to negative 8. Because it starts at negative 8, that would be that minimum on the parabola. And it goes up further, it goes up forever. And the solutions, I do have solutions here. It's not no solution because it's crossing the x-axis at positive 2 and negative 2. So my solutions are 2 and negative 2. If I compare that to the parent function, it was a vertical translation down 8 or of negative 8. And then positive 2 makes it a stretch or more narrow than the parent function. And you could kind of see it. It's hard to see a little, but you got to know that your stretch and your narrow go together. So those are pretty much all the graphing problems you have. So this is kind of a sketch of parabola with a given characteristic. Just put your pencil down and watch. And if you're having trouble with these, you can go to Desmos to figure these out. So if I'm going to draw a parabola that opens up and the vertex is 0, 3, and that's all the information that I have. So I know that I'm going up by 3, and I know that it opens up like a smile. So I'm going to assume this is y equals x squared plus 3, a being the same as the parent function. So if I were to graph it, I could go over 2 from the vertex and go up 4, and then over 2 from the vertex and go up 4. So that would be the parent function, except instead of 0, 0 being the vertex would be 0, 3. Okay, and then down here, if the parabola opens down, I know that a is negative. It has a vertex of 0, negative 4. I know that 4 is my z. And then one of the x-intercepts is 2. Okay, so let's graph that and see if we can come up with maybe an equation for it based on what we know. Let me get rid of this old picture. I guess we'll just change colors because I can't erase it for some reason. Okay, so 0, 4. So 1, 2, 3, 4. We're opening down, and we know that the x-intercept is 2. Well, it would have to have 2 x-intercepts, not just 1. It would have to be 2 and negative 2. So this is also the parent function. It's just because it's the difference here is over 2, down 4. So that means my points would go here and here. And I could draw it this way, trying not to make that bottom pointy. And then I could write the equation. So this would be y equals, my parent function was the same, so there was no stretch or shrink. So x squared. And since it was 0, 4 pointing down, that's plus 4. And since it's opening down, it's a negative x squared. So this would be my equation that I just graphed. I could figure it out from the characteristics that it gave me. Okay, and then the last thing we need to do here is we need to find the zeros, because you have some of these on your homework. So finding the zeros is the same as finding the roots or the solutions. And what we're going to do for this is we're going to factor them. Okay, we're not going to graph these, we're going to factor them. So it's in standard form the way it is, and I'm going to take the f of x or the y, since they're the same thing, and I'm going to change that to 0. And then I'm going to factor the right-hand side where the x squared is. So that is the difference of squares. This would be x and x. The square root of 9 is 3. And then because the middle is gone, it would be plus or minus. And then I would set each one of these equal to 0. The binomial here, x plus 3 equals 0, and x minus 3 equals 0. So here I have to subtract 3 on both sides, so x is negative 3. And here I add 3 on both sides, so x is 3. So the two roots or solutions or zeros of this particular function is 3 and negative 3. And remember what that means. It means that's where the parabola is going across the x-axis. So same thing over here. I would take the y out and in this place put 0. And I can factor that difference of squares on the right-hand side. So 0 equals, so if I take the square root of x squared, that's x and x. Square root of 81 is 9 and 9. And then because the middle term is different, or the middle term is gone, I would put plus minus here. So x plus 9 equals 0 is going to be one of the solutions. And x minus 9 equals 0 is the other one. So here I'm subtracting 9 on both sides. So one of the roots is negative 9. And here I'm adding 9 on both sides. So the other root is positive 9. Okay, down here, this is almost a difference of squares. So again, I'm replacing the f of x with 0. And I'm going to factor out a negative 1 as the GCF, and then that will make it a true difference of squares. So I can factor that. Square root of x squared is x. Square root of 49 is 7. And because that middle term is missing, it's plus minus. So remember, anything with an x gets set equal to 0. That negative 1 does not get set equal to 0 because it doesn't have an x. So x plus 7 equals 0, and x minus 7 equals 0. So here I subtract 7, and here I add 7. So my two solutions are negative 7 and 7. Last one. So here I'm looking, first of all, this one front is negative, and it has a GCF of 5. So I'm going to change that y to 0 and factor out a negative 5 from both. So that's going to leave me inside the parentheses with x squared minus 100, which is also a difference of squares. So if I factor that, that's x and x as the partner, and square root of 100 is 10. And I do opposite signs because it's a difference of squares. So both of them get set equal to 0. And then we solve. So we're going to subtract 10. And here we're going to add 10. What? That's supposed to be an add. There we go. There are my two solutions. And you can see it's the same number, just plus and minus for each one. And all of these are going to be difference of squares because there's no bx. In the next section, there'll be a bx. They won't just be difference of squares, and you'll have to remember how to factor to get all that done. Okay, it says error analysis. The student claims the correct equation is written above the graph. Correct the student. So the student is incorrect. So you can see that the vertex here is 0, negative 4, and that they plugged in 1 and got 6 and negative 6. So there's a couple mistakes here, I believe. So first of all, this part here, the c squared, should be minus 4, not positive 4. Also, if this is a parabola, it should be squared. So x squared minus 4. For one thing, that's a really big deal. Okay, and then it looks like it may be near, although it's not really asking for that. If I were to actually graph what's here, this is a linear equation. This is a linear equation, and so is this one over here. All right, let's change it. Okay, so if we plug 1 in here, so 1 squared minus 4 is -3. So 1, -3, and -1, -3. Okay, and we could plug 2 in. 2 squared minus 4 is 0. So 2, 0, and there we go. So if we wanted to regraph it correctly, it would look like that instead of what they've got there. And my equation would be like this. And you could put f of x here if you wanted. Let's go ahead and change this to squared, because otherwise it's linear or a straight line. Okay, so it looks like they've got the vertex correct. At least the point is correct based here. This shouldn't be a +8, not a -8. There's all kinds of mistakes here. It looks like 1, 1, going over 1, down 1, over 1, down 1. That's correct. Over 2, down 4. So there's no A, except that it's opening downward. So since it's opening downward, this should be a -x squared. So there's a couple things wrong there, but not a bunch. This one over here was much worse. So that second one was a lot easier, just opening down, making that 1 there, -1. All right, so let's talk about homework real quick. So you're going to go to the Big Ideas website, and if you don't know how to get there, you're going to the resource portal on the Perry Township website. Shh. Sorry, the dog is barking. The resource portal, and then you'll click Evaluate, and you'll see the Big Ideas app. And then you're going to go to the yellow student, it's yellow, I don't know what it's called, Student Dynamic website, something like that. It's yellow though, I believe. And then you'll go to Assignments. Okay, so if you're planning to do this online, which is what I would very much like for you to do, to submit this online, you'll find the assignment for 8.2. Okay, if you don't have internet or for whatever reason you cannot do this online, you can do this on paper. You're going to go to page 429 and 430, and you're going to have to do that on paper, including the graphs. You'll have to graph everything, where these people over here will not have to graph everything. Theirs is multiple choice, yours would not be. And you can look at Canvas for the exact assignment. I know it's page 429 and 430. So you'll have to take a picture and send that to me. I much prefer the online, but I understand if you don't have the capability of doing that. So I hope this was interesting to you. I miss you guys, and I hope you're taking care of yourselves. So hopefully we'll talk soon. Bye-bye.